Okay, this next one is y equals e to the square root of x plus the square root of e to the x. So the first thing I'm going to do is just rewrite this. X to the 1/2 power and e to the x raised to the 1/2. And then, so the first one is, now I'm going to take the derivative. So it's just going to be e x to the 1/2 times the derivative of this u. Plus the second one is going to be, bring the 1/2 out front. 1/2 e to the x to the minus 1 power. So we have chain rule here. Times the derivative of the parenthesis. Okay, so the next thing we're going to do is, this is just e to the square root of x, so I'll rewrite that using the square root. The derivative of this, just simplified, is going to be here. Bring down my 1/2. The derivative of e to the x is this e to the x that's in the top. And this e to the x, I brought it down to the bottom as a square root. Now, the reason why I wanted you to see this one, and I'm just kind of talking you through it, is because the simplified version of it, so e to the square root of x times 1 is just the numerator. Bring down this as my denominator, plus e to the x in my numerator, 2 square root e to the x. Is the textbook gives answers like this, and so I want you to see one of your options for simplifying this particular term over here. If I multiply by the square root of e to the x, whatever you do to the numerator, do to the whatever you do to the denominator, do to the numerator as well, it would simplify to the square root of e to the x over 2. So I just really wanted you to see that simplification method, just in case you need to use that to be able to check an answer. Okay, so our next one, y equals e raised to the x natural log of x. So the first thing we want to do is we're going to take the derivative. The derivative of this is just that times the derivative of this u here. But you can see that this is two terms, so it's going to be a little bit detailed when we get to that point. So here I just carry down. Now when I take the derivative of this, it's going to be first times derivative of second plus second times derivative of the first. We'll have product rule there. Just carry this down. The derivative of the natural log of x is 1 over x. The derivative of x is 1, so when we simplify that, we're just going to bring this down. This reduces to just 1, and this just becomes the natural log of x. So nothing too complicated there. Just want to make sure you're careful when you have product rule here. All right, so number 10, what if you have the natural log of e to the x and we take the derivative of this? So y prime is going to be, first of all, the derivative of a natural log function is 1 over e to the x times the derivative of that e to the x. So I just carry down my 1 over e to the x. Now what is the derivative of e to the x? Just e to the x, so what happens there? Y prime is just simplifies to 1. Good. Next one, let's do a trig function now. So y is equal to the sine e 2x. Sine times e to the 2x. When we take the derivative of this, we're just going to get, what's the derivative of sine e to the 2x? Cosine e to the 2x, but we have to do the derivative of the e to the 2x. So y prime is going to be, let's carry this down. Now let's work on the derivative over here. What's the derivative of this? Of course it's going to be e to the 2x, but we also have to account for the derivative of the u, which is 2. And then that's not really going to simplify any further than that. You can move the 2e to the 2x out front if you wanted to, but that doesn't necessarily matter. Okay, just to do a quick review of this one, y equals e raised to the sine of 4x power. So when we take the derivative, we have the derivative of this is just that times the derivative of what that u term is going to be. So it's e to the sine of 4x times derivative of that u term. Now you just carry this down. The derivative of the sine of 4x is going to be the cosine of 4x, but we also have to have the derivative of this, which is 4. So when we simplify it, if I just bring this term to the front, I'll have 4 cosine 4x, and then I have my e to the sine of 4x there. So quick little reminder on that type of problem. And the next one we're going to work together involves a trig function as well, but how many terms is this? This is going to be 2 terms, so we're going to use our product rules. So go ahead and write that first step out. First times derivative of the second plus second times derivative of the first. Okay, the next step I want you to start simplifying this. So let's bring down this term and focus on the derivative here. What is the derivative of the cosine of 3x? Negative sine of 3x. But then we also have to, let me put a parenthesis, multiply that by the derivative of this term, which is just a 3. Bring down cosine of 3x. And what is the derivative of this? First of all, it's going to be e to the negative 3x, but we also have to do the derivative of this term, which will be negative 3. Okay, simplifying this all together, let's look at this and see what we would get. Negative 3 sine of 3x. So basically I just rearrange this and I'll have e to the negative 3x plus negative 3 cosine 3x times e to the negative 3x. I can just take that plus out right there. So what do they have in common? Let's look for a GCF. So y prime is equal to a negative 3 comes out, also an e to the negative 3x. So that would leave us with a sine of 3x plus a cosine of 3x. Right? And that looks like about as simplified as we can get it for now. Our next example says use implicit differentiation to find y prime, and our given is going to be x e to the y plus 2x minus the natural log of y plus 1 is equal to 3. Okay, so I rewrote it because our first step is to take derivative with respect to x of every term. So we're going to take d dx of every term, and I just want to show this before we start calculating so we see that step right there. Now for this first one, how many terms is it going to be? 2, so we're going to have to do product rule there. So that's going to be first times the derivative of the second plus second times the derivative of the first term. Okay, now we can go ahead and calculate. What's the derivative with respect to x of this term? Just 2. Okay, what would be our derivative of the natural log of y plus 1? So first of all, that's just going to be 1, I'll have that minus sign, 1 over y plus 1. But this is a y variable and we're taking d dx of it, so what do we have left? We need to say dy. Or dy dx. Okay, and what's the derivative of just 3? Now this is also I'll put that 1 there because we do 1 over this times the derivative of this, which is just a 1. So I'll put that for the derivative of y plus 1 is just 1. So we make sure we have that showing. Alright, now let's come to simplify this product rule. So we're just going to bring down our x. What is the derivative of e to the y? It's just going to be e to the y, but since it's a y term and we're taking d dx of it, we're going to have dy dx plus I carry down e to the y. What's the derivative of x? Just 1. So let me just rewrite all this. Minus 1 y plus 1 dy dx is equal to, I don't know why I had a 3 there. Talking right at the same time is sometimes a challenge for me. Okay, now our goal in solving for dy dx is that we want all the dy dx terms, which this is a dy dx term, and this is a dy dx term, to be on the left, and everything that's not a dy dx term to move it to the right hand side. So let's do that. So we'll have x e to the y minus 1 over y plus 1. Both of those are dy dx. So if I group those two highlighted ones together, now what happens if I move this one to the other side? It becomes negative e to the y. And what if I have moved this to the other side? I get minus 2. Okay, ultimately our goal is to get dy dx by itself. So what do? Divide both sides by that parenthesis. And whatever you do to one side, you do to the other. Okay. Now you could pull a negative sign out front if you want. The rest is just simplifying or being, pull a negative out. That would just give us e to the y plus 2 over x e to the y minus 1 over y plus 1.